Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, today we are going to discuss about the definitions and terminology related to array concepts in C language. And also we'll solve a number of problems using array concept in C language. So, let us start with what is an array. Now, what is an array? An array is a collection of homogeneous data elements. Now, the idea is to store multiple elements of the same type. Now, it will be very easy for us to calculate the position of each element if we will store at a common place. Now, how to calculate the position of each element? It is simply the first element will be stored at index number 0. Then the second element will be in the consecutive next memory location. So, you can simply add the offset to the base value. Now, the memory location of the first element of the array is known as the base value. With that offset value, you can simply add and you can find out the position of an element in the array. Now, only if a group of characters are stored in an array, then it is called a string. You can call it as a character array, but it is most popularly called it as a string. But whereas if you will store a group of integers or group of float values, then it is simply called as an array only. So we'll simply call it as an integer array or character array. Now let us go for this example. Suppose here we have stored some character U, B, F, D, something, these characters, and these are known as the index values. And this is known as the address. So the address of the first element, if you know, then you just add the offset value as 1, then the address of next element is 201. Then the offset value is 2 from the base address. This is your base address. Plus offset you have to add. So offset you add. So this is the address of the next element. So like that, the memory address of each element can be identified. Now, similarly, if you will see that, if you will see this an integer array, which is a group of integers are there. Now, these are the array indices, and array indexes starts from 0, and the length of the array is 9 elements, and the first index is starting with 0. So, the last index is always n minus 1. That's why 9 minus 1 it is 8. So, this is the introduction to arrays. Next, how will you find out the size of the array? Now, normally the array has fixed size. That means once the size is given to it, it cannot be changed. You cannot shrink the array or you cannot expand it, because the memory allocation to arrays is static in nature. So, whenever you declare the size of the array, that much memory will be allocated to the array based on the data type. Now, the reason that we cannot do expansion because we cannot change the size, and as you do not know whether the next memory location will be free to use or not. Okay. Similarly, you cannot shrink the array size, because whenever an array is declared, the memory is allocated statically, and the compiler is the only one who can destroy the space. You cannot simply shrink it. So, expansion and shrinking of the array size is not possible, because that's why we say that arrays are static in nature. So, whenever you want to use an array, please declare the size of the array based on your need. Now, what are the different types of indexing that is used in the array? So, basically it is of 3 types. One is called 0-based indexing, 1-based indexing, or n-based indexing. 0-based indexing means the first element of the array is indexed by a subscript 0. So, most of the programming languages use 0-based indexing, including C language. Similarly, if the first element of the array is indexed by a subscript of 1, then it is known as 1-based indexing. Similarly, if the base index of an array can be randomly chosen or freely chosen, then it is called n-based indexing. Now, in array concept in C language, will use the zero based indexing. So the first element will have the index number 0, second element will have index number 1, third element will have 2, and the last element will have n minus 1 as the index, where n is the number of elements. So you can see over here, the array of 0 refers to the array variable. The ARR is the name of the array, and 0 is nothing but the index of the array where the element needs to be accessed. So an element in the array can be stored or accessed or retrieved based on the array index only. Okay. Now let us look at the example. Suppose there is an array of size 10. There is an array of size 10. 0, 1, 2, 3 up to 9. So then array of 0 contains 5. That means at the 0th, so this is the name of the array. At 0th index you have stored 5. Now how will you retrieve this value? So this is called storing the value into the array. You have stored it. Now I want to retrieve it. So while retrieving also, we have to write down array with its index. So ARR of 0 will retrieve the value 5 as the output. Now, why do you need arrays actually? So we can use normal variables as n1, n2, n3 or v1, v2, v3, any number of variables we can use in our programs. But whenever you want to store large quantity of data or large number of instances of the same type, then it becomes difficult to manage so many normal variables. So instead of managing so many normal variables, if all the instances belongs to the same data type, then it is better to go for an array. So the idea of an array is to represent many instances in one variable of similar type. So this is the concept of an array. Now, what are the advantages of using array? The first advantage is it allows you for random accessing to elements. That means you can store an element or retrieve an element based on the index. So you can do insertion, deletion, all these operations based on the index position only. Now, this makes the accessing elements based on the position, it makes it faster. Second thing is arrays have better cache locality that makes big difference in the performance of the arrays. Now, array represents multiple data items of the same type using a single name. So, these are the advantages of array. So, when you have a group of elements of the same data type or same nature, then you go for an array concept where you store huge amount of data of the homogeneous type and you do the operation. So, array is the simplest data structure for use. Next, let us talk about what are the disadvantages of using arrays. Now, we cannot change the size of the array. That is, once you have declared the array, you cannot change its size because of static memory allocation. So, static memory allocation means during compile time only, the memory is allocated based on the size of the array. So, apart from the static memory allocation concept, insertion and deletion operations are possible on arrays, but it is difficult to perform as the array elements are stored sequentially or in consecutive memory locations. And the shifting operation, if you want to insert a new element, then you need to shift the existing element by one position. And if you want to delete an element also, then you have to fill that gap by shifting the elements to that place. So the shifting, when the size of the array is very large, then the shifting operations are very costly. That means the time required to do the shift operations will be large. So hence it adverses on the performance of the arrays and the time complexity will increase. Now, let us discuss some of the applications of the arrays. Now, array stores data elements of the same type. So, whenever in any application, if you want to store bulk amount of data of same type, then go for array concepts. Second is, arrays are popularly used for CPU scheduling mechanism, where where you can store the different process times or the arrival times of the processes, the waiting time of the processes in different arrays. So arrays are popularly used in CPU scheduling algorithms. Next, the arrays are also used to implement other data structures like stacks, queues, heaps, hash tables, and so on very popularly. So arrays can be used in multiple applications. Now, let us go to our DevC++ compiler and execute a number of programs using arrays. Now, let us start how to work with arrays with the simple examples. So, let me write first the header file hash include stdio.h. Now, here in this example, how to declare an array and how to display the elements of the array, that we will first talk about. So, as we know that static nature of the array, how to declare an array. So, let me declare here one array integer ARR of 1. Now, if I want to make it static, then suppose I am declaring the size of the array as 10. What is the meaning of it? Meaning is that how much memory is allocated. 10 slots or 10 consecutive memory locations will be allocated to store 10 integers, and size of each integer is 4 bytes in a 32-bit computer. So total 40 bytes of space will be allocated for storing this 10 integers in consecutive memory locations. Okay. Similarly, suppose in your latest compilers, if you will declare the value of n as 10 and then you want to declare an array of size n, that is also allowed. Okay, that is also allowed. Then the third way of declaration is, suppose I am declaring an array without mentioning its size. Okay, but if I want to assign some values, suppose I am assigning some values 10, 20, then 30 and 40. If I am assigning some values like this, then compiler automatically finds it out what is the size of this array. Similarly, if I will write ARR of 4, there is another way, and I am mentioning the size of the array as 6, but while initializing the values, suppose I am giving only 4 values, then what about the remaining values? The remaining values, the last 2 values will be either taken as garbage or 0. That depends on the compiler. So, now these are the different ways of array declaration I have shown you. The first one is I have written directly the size of the array. Second one, I have used a variable n and I have declared the array of size 10 only. In the third case, I have taken an array with some elements without mentioning the size, but the compiler will automatically find its size. And the fourth case, I have taken an array of size 6, but I have stored less number of elements. So the remaining elements will be filled with either zeros or garbage. That depends on the compiler. Okay. Now let us see how to display the content of the array. Now for displaying the content of the array, let me take a looping variable I, and for displaying the content, and you have to write down a loop. So I am writing for I is equal to 0, then I less than 10 and followed by I plus plus. Now using this for loop will run for 10 times, and every time it is going to display percentile, let us say 5d. 5 is the width or the spacing that I want to provide between the elements, and followed by ARR of 1 of I. Okay, let me show you in this example to the contents of the 4 different arrays that I have declared. Now, in the first array, I have just declared the array, but I didn't store anything. So first let us check that the array of size 10 contains what. Now, first let us compile and run the program. Now, you can observe over here on the screen that the 10 elements in the array contain some garbage value. Okay, let me show you here. by changing this to /n, and let us compile it again. So array of 1, if you will see that it contains some garbage values in all these 10 locations. But whether you will get garbage or 0, that depends on the type of compiler, C compiler that you are using. Okay. Now let us change this to array of 2, where we have declared a variable to mention its size. So what is the value that is in array 2? So let us run it again. So you can see that this is also giving the same kind of output, where all the 10 locations are containing some garbage value. Now let us display the content of array 3, where already the array is initialized with 4 values, but we have not mentioned the size. So let me change this to 4. So what will be the output? So here you can see exactly the size is automatically determined, and it is 10, 20, 30 and 40. And in the next example, if you will make it as 6, the array size is 6. So the loop should run 6 times, and we will change this to array of 4. So when you will change this to array of 4, then what will be the output? So you can see over here, the first 4 index elements contains 10, 20, 30 and 40, and last 2 are simply zeros. It may be zeros or garbage again, that depends on the compiler. So you have to verify it. So whenever you take extra elements, whenever you declare extra space, then that is filled by some garbage or zeros, that is by the compiler. So in this example, we have seen that how to declare the array and how to display the elements of the array. Okay, now the next example that we will go for is in arrays, there is no index or array bound index checking. So let us do that program. Okay, so let me change over here, no index out of bound checking in arrays. No index out of bound checking in arrays. So one of the drawback in C language is that it will not throw any error whenever you are going out of the boundary of the arrays. So how will you check that? Suppose here I am declaring an array of size 2. That means what are the array index positions? Array index positions are array 1 of 0 and array 1 of 1. Okay, index position 0 and 1. But while printing, suppose I want to access an index position which is not there in the array. So if I will write that your array 1 of index position 3 or 4, okay, simply let me copy this line, and similarly, if I am giving any negative indexing like -2, okay, but what I will observe from here? So no index out of bound checking means what? So you can see that originally the array size is 2. That means it contains index position 0 and 1. But I'm trying to print the value what is there at array index position 4, and I'm using a negative index also. Then what I will get? Now you can see that some output I am getting which is not relevant. Okay, so I can say simply these are garbage values or irrelevant outputs I am getting, because it is not checking the boundary conditions. So that is one of the drawbacks in C language, you can say. Okay, now suppose similarly, if you are trying to initialize an array, okay, let me write initialize an array with more number of values than its size. Initialize an array with more values than its size, then what will happen? For example, there is an array of size 2. Okay, let me initialize with some 4 values, 10, 20, 30, 40. Okay, and I want to print the content of the array. Then what will happen? Will it throw any error or not? So you can see over here that let me write down that for loop for I is equal to 0, I less than the size, that is, let me take 4, okay, then I plus plus. And inside this, I want to print the content of I. Let me remove this and declare one looping variable I. So what we are trying to do over here? Now, what you have done, we have declared an array size of 2, but we have assigned with 4 values. Now, let us see what will be the output. Now, you can see over here that, let me put a semicolon over there, comma over there, and let me run it. Now, can you see here that it is printing the values 10 and 20 properly. First 2 values it is taking. The next 2 values, it is showing some garbage. Okay. As just now I said previously that it is not doing any boundary checking. So that is the reason in the array index number 2 and 3, some garbage values it is coming. But this is also another drawback in C language, that it throws some warning that excess elements are there in array initialization, but it is compiling properly and giving you some output. So this is just treating that if an array size is less than the number of elements assigned to it, but still it is not throwing any error. Just it is giving some warning and leaving it and compiling successfully. So this point also you have to note it down. Now, after this, let us do some operations on the arrays. So let us go for what are the operations of the arrays. Now, for doing the operations, what are the basic operations in any data structure? So array is a linear data structure. So the basic operations on arrays will be first insertion, then deletion, searching, traversing, and so on. So these are the basic operations on any array: insertion, deletion, searching, traversing, and so on. So let us do one program how to insert an element to an existing array. So first we will go for insert an element to an existing array. Okay. So how to do with this program? Now let us declare an array, integer an array, and that array is having n number of elements. I is the looping variable. Where you want to insert an element? Now take its position and which element you want to insert. Read one element. Okay. So first we have to read what is the value of n. So write down printf enter n value. Enter n value. Now after reading the value of n, write scanf %d ampersand n. Then there are n elements that are there in the array. So let us read the elements. So printf enter elements into the array. Into the array. So how will you enter the elements? We need a loop for it. So let us write for I is equal to 0. Then I less than n I plus plus. At a time, one elements will be read. So you write down scarf %d, okay, and then ampersand ARR of I. Now here we have done a mistake that we should declare an array of some size. Okay, let us take array of size 10. Okay. Now based on the value of n, you can declare, you can store 5 elements, 7 elements, maximum 10 elements. So here we are reading the elements into the array. Next, you read that in which position you want to insert the element. So write down printf, enter the position. Enter the position. Position to insert the element. Then read that position, scanf percentile d, comma, ampersand POS. Now similarly, read the element, which element you want to insert. So for that, let me copy these 2 lines and paste it over here. Enter the element. Okay, and read that element over here. Okay, now after reading the element, we have read elements into the array, we have read the position where you want to insert the element, and also we have read the element which you want to insert. Now what logic you have to write to insert the element into the array? Now first of all, check it whether the position is within the boundary or out of boundary. So based on that, you can check whether it is a valid position in the array or invalid position. So for that, let me write one if condition, that if the position value is greater than n, then I can simply print invalid position, invalid position. Okay, and otherwise if it is a valid position, then I need to insert that element. So for inserting, I need to shift the elements first, and you have to create one empty space there. Okay, so how to shift the elements? For that, you have to write down a for loop. So let us write a for loop. So for I is equal to n minus 1, then followed by I greater than equals to position minus 1, and what you have to do? You have to do I minus minus. Now, in that, how to do shifting of the elements? For shifting the elements, write ARR of I plus 1 is equal to ARR of I. So, this is the logic that you have to shift the elements by one position. Then you will create some space there. So, whenever you will create a space, now you insert your element by writing your position minus 1 is equal to the element. Okay. Now, after insertion, see that whether the element is inserted or not. So, print the elements of the array again. So, write down printf display array elements. Okay. How will you display the array elements? So, for that, again you need to write down the for loop. Okay. So, write down for I is equal to 0. Now, one element got increased. So, I less than equal to n you have to write. Okay. Then I plus plus. Now, display the contents. So, printf percentile phi d, for example, and ARR of I. Now, this is the logic. What we have written? For first, we have written how to shift the elements by one position, and then we have inserted the element into the appropriate position. Then we are displaying the content of the array. Now, save this program and run it. Now, it is asking me to enter the value of n. Suppose n contains 5 elements. Okay. Now, enter those elements into the array. Suppose the elements are 10, 20, 30, 40 and 50. Now, let me check. So, why it is not asking to read the position? Now, let us check what is the problem. So here what is the problem? We have missed the ampersand. So please put the ampersand, which is the address operator. Okay. Now let us run it. N is equal to now 5. Then enter the elements. So 10, 20, 30, 40 and 50. 5 elements I have entered. Now enter the position to insert the element. Suppose I am giving position is equal to 3. Now it is asking me to enter the element which you want to insert. So I'll write here 25 I want to insert over here. Now you can see that after inserting it is 10, 20, 25, 30, 40 and 50. So the element is inserted in appropriate place. But in this example, we have taken only 5 elements. So we have done the shifting operations. But whenever the number of elements are more, then the time complexity of this problem will increase. So that's why insertion and deletion operations are costly. So that you have to keep in mind. So the first basic operation on arrays is called insertion operation, and we have done insertion operation over here. Now let us go for the deletion operation in the array. Then for doing deletion operation, let us copy this program and open a new window and paste it first. Okay. So let us do the changes. So the operation that we are going to do over here is called delete an element from an array. Delete an element from an existing array. So what are the things that is common to the previous program? That we have to take an array. So array of size 10 we have taken, and n is nothing but the number of elements in the array. I is a looping variable. Okay, and remove this position. Okay, otherwise keep this position, because from which position you want to remove an element is also required. Okay, so you have to specify the position, and after that we will go for, so element we need not read it. So element we will remove from here and read the value of n, read the array elements and enter the position to delete the element. Okay, this is also common. Then check when the element reading is not required. So I am removing from here. Okay. So if the position is greater than equal to the position from where you want to delete the element, if the position is greater than equal to n plus 1, then we simply write deletion not possible, because it is beyond the boundary. Deletion not possible. Okay. Otherwise it is possible. So how to do deletion? For that we will write down the logic over here. Okay. So how to write down the deletion? So whenever you delete an element, that empty space you have to fill it up. Okay. By shifting the elements again. Again the operation that we need to do is called shifting the elements. So for shifting the elements, what we will do here, let me take here from position -1 till n minus 1. Till n minus 1. So that empty space will be filled by shifting the elements. And what do you have to do? You have to do I plus plus. And here array of I is equal to array of I plus 1. You have to do it. Okay. And this line you have to remove. Then after that you have to display the elements. So one element has reduced now. So you can change this to n minus 1. Okay. Now let us save this. So write down a name, deletion in array, and save it as a .c file, and then compile and run. Enter the value of n. Suppose I am taking 5 elements. What are those elements? Suppose 10, 20, 30, 40 and 50. Okay. Then enter the position to delete the element. Suppose I want to delete the third element. Then after deletion, the third element 10, 20, 30, 40, 50. That means 30 should be deleted. Okay. Based on the index position, 0, 1, 2, 3 is nothing but 40. So 40 should be deleted. And 50 should come. So let us check the program that Veritha mistake in the logic. Let us find it out. Okay. So here, see, from I is equal to position minus 1 till your this should be less than, till it is n minus 1 I plus plus. So array of I is equal to array of I plus 1. And now let us check it. So let us compile and run it again. Now enter the value. So it is 5. So 5 elements are in 10, 20, 30, 40 and 50. Now enter the position. Suppose I will give position 3 only. Then 10, 20, 40 and 50. So because I have taken here from position minus 1. So 10, 20, 40 and 50 are coming. Now let us take another test case and let us check it. Now suppose I am taking my 6 values. 1, 2, 3, 4, 5 and 6 values are given. Now enter the position to delete an element. Suppose I am giving second position. So you can see here 1, 3, 4, 5, 6. So output is now coming correctly. So this is the operation called deletion operation. Now let us paste the output over here. So the second basic operations in the array data structure is called deleting an element. So in deletion also we need to shift the elements to the next position. Now let us go for the third operation, that is called searching an element. So for that, let us copy paste this program. So Control C, go to a new window, Control V and do the modifications for doing the third operations. So what is our third operation? Searching. Searching an element from an existing array. Okay. So the output will be either the element is found or not found. So if the element is found, then it is in which position? Okay. Which index position the element is found, that we have to check it out. So what are the common things? So for searching, let us take an array n and I is the looping variable. So enter n value, read the value of the read number of elements, then read the elements into the array, and then you have to position we do not need, so we'll remove from here. Okay, now position we need not check because for every element we need to repeat the same process. So here we will change our logic. We will remove this for loop also, and we do not need this printf statement. So what we have to do? For I is equal to 0, for I less than n, for all elements I plus plus, you write down if your array of I is equal to the element that you are looking for. So this is nothing but our search element. Okay. So for this program, let us take one search element. First we read. So after reading the elements into the array, read the search element. Printf enter the search element. Scanf %id ampersand search. Search is the name of the variable. Now let us check with each and every index position whether it is matching with the search element or not. So if array of I is equal to search, that means the element is found, right? So if element is found, then what you need to do? Then we can take any flag. We can take any flag over here. Flag is initially suppose 0, and if it is found, we can simply do flag is equal to 1 and we can break that if element is found. Otherwise, it will continue the loop. So after coming out of this loop, we can simply display that the element is found. So let us remove this line and write down one if condition. If flag double equals to 1, then printf search element found at percentile D location. Okay. Now, so that location is nothing but the value of I. So, as the index starts from 0, so we'll make it a I plus 1. Okay. Now, let us save and run this program. So, this is called searching in an array. Save it as .c file. Okay. And compile and run. So, n value is suppose 5. Enter 5 values 10, 20, 30, 40 and 50. Now enter the search element. Suppose I am looking for 30. So it should tell me that search element 30 is found at the third location. Okay. Now let us try for another test case. First, let me copy paste this output here. And let us test it again. N value is suppose 6 elements are there. Okay. 1, 2, 3, 4, 5 and 6. Now enter the search element. I want to search for 9. Then it should say that element not found. Why it is not coming? Because I didn't write down the condition. So in our if condition, we can put an else part here and printf we can write down element not found. So you just write down this simple statement to display that the element is found or not found. Let us check again. N is equal to 6 element. The elements are 1, 2, 3, 4, 5, 6. Then element I am searching is 8 and element not found. Okay. So this is the third operation in an array that we want to search an element in the existing array. So in today's video, we have learned about the basics of array concept, the operations on the arrays, and we have learned how to do programming for inserting an element or deleting an element or searching an element to an array. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.